All right, we're going to look at Chapter 6, Section 2. This is 6.2. By now you should have completed 6.1. There were 4 different sections for 6.1, and then we took a quiz, so make sure you get that quiz taken if you haven't yet. And this is Section 6.2. We're going to talk about exponential growth functions. To be an exponential function means that we're going to have exponents involved in our equations. An exponential function is a function in the form y equals a times b raised to the x power. Okay, so we're going to have an exponent for our x variable. A is the initial amount, that's the amount we start with, and b is the constant ratio, so that's by how much it's going up by. For beginning, you're going to be able to tell whether the graph represents an exponential function or not. Okay, with this graph, we see that each time it's going down by 5. The output, each time the x value, the input goes up by 1, the output is going down by 5. That does not represent an exponent. That represents a constant value. That would be linear if we were to put that on a graph. So this is a no. That is not an exponential function. When I look at this, as the x values increase by 1, what's happening each time? Okay, each time you're seeing it's dividing by 2. It's being cut in half. It's being divided by 2, it's being divided by 2, it's being divided by 2. So that would be a yes. That is an exponential function. Okay, as the x values increase by 1 here, what's happening to the y values? We're looking at the y values each time. To go from 5 to 1, we're dividing by 5. To go from 1 to 1/5, we're dividing by 5. To go from 1/5 to 1/25, we're dividing by 5. So that ratio is constant. It's constantly being divided by 5, so that is a yes. That's exponential. And then this one I can tell you is yes just by looking at the shape of the graph. I know that's going to be exponential. But again, if you look at the y values here, okay, what's happening each time with the y values? I skipped one right here. So if you look at the y values as the points go up, to go from 4 to 8 to 16 to 32 to 64 to 128, you're multiplying by 2. That's a constant ratio. Okay, so this is a yes as well. And that's a good example to look at. Those are the shapes of our graphs this unit when we start graphing these. Okay, so that's how you can tell whether something's a function or not. Then it's going to go on and it's going to ask you to actually do the graphing. Okay, and just like with any other graph, when we first started graphing in a previous chapter, we always started by making a table of values. And that's how we're going to graph these exponential functions. We're going to make a table of values. It says graph the function y equals 2 raised to the x power. So your x value is your exponent. I'm going to put in a -1, I'm going to put in a 0, I'm going to put a +1, and I'll put a 2 in. Okay, again, how many of these you put in can vary. I would say put in at least 3 values, put in some negatives, put in some positives. Okay, when I have 2, if I put -1 in there, y is equal to 2 to the negative first power. Think about how we simplify a negative exponent. 2 to the negative first is the same as 1 over 2 to the positive first. So that would be 1/2. If I put the 0 in here, I would have 2 to the 0 power. Anything to the 0 power equals 1. If I put a 1 in for an exponent, 2 to the first power is 2. And if I put a 2 in, 2 to the second power is 4. So I'm going to plot those on the graph. When I had a -1, I was up at a 1/2. 0, 1, 1, 2, and 2, 1, 2, 3, 4. Okay, and remember what that shape looked like? This time the shape is going to go from here, and it's going to go up quickly. Okay, we put arrows on both ends of our curve here. This represents, actually represents exponential growth. Okay, it's going to be going up as we move to the right and the x values get positive or greater. We are going to increase our y values rapidly. So that's actually exponential growth. Okay, I can do the same thing with a base of 5. Okay, I'm going to put in a -1, 0, 1, 2. See what kind of values I get. 5 to the negative first power would be 1 over 5. 5 to the 0 power would be 1. 5 to the first power would be 5. 5 to the second power would be 25. Now 25 is going to go off my graph. I'm not going to try to put that on there, but I'm going to try to graph these three. Negative 1 down at 1/5, that's kind of hard to graph. It's really close to 0, just above 0. 0, 1, you can graph that, and 1, 5. 1, 5 would be up there. So you can see this one goes up a little quicker than the last graph. But again, it's going to come down here, and it's going to go up. Okay, now, on this end of the graph, it's going to get closer and closer to 0. But there's actually no value I could put in and raise 5 to what power to get 0. That doesn't exist. So this graph, I'm going to do a little bit better job graphing it. See if I can. This graph, as it comes down, is going to get closer and closer to 0. But it's never going to touch the axis. It's never going to actually get to 0. And it's not going to cross over and go into the negative range. Okay, you've got a little more complicated here. We're going to evaluate the power first, and then we're going to do the multiplication. So when you make your table of values, and I'll put in negative 1, 0, 1, and 2. When I put that value in, 2 to the negative first power, okay, I have to take my answer times 3. So this is a half. 1 over 2 to the first. That's a half times 3. That's going to be 3 over 2. Or 3 over 2 is 1.5. When I put a 0 in here, that's 2 to the 0 power. 2 to the 0 power. Well, 2 to the 0 power equals 1 times 3. And you get 3. Okay, if I put a 1 in here, if I make that a 1, 2 to the first power is 2 times 3, that becomes 6. And if I put a 2 in there, we've got 2 to the second power, that would be 2 to the second is 4, times 3 is 12. And again, 12 is going to go off my graph, so I'm going to rely on the other points. So negative 1, I'm going to be up at 1.5. 0, 3. 1, 1, 6, about right here. Okay, so I'm going to make a curve like that. Okay, and there's my graph. Okay, you can do the same thing over here. You can make table of values. I'm going to put values in for x. 3 to the negative first. I always evaluate the exponent first. So I'm going to have 1/2 times, if I put a negative 1 in there, that's going to be 1 over 3 to the first. That's going to be a fraction of 1/6. Okay, if I put a 0 in here, I'd have 3 to the 0 power. Well, 3 to the 0 is 1 times a half. You get a half. And if I put a 1 in there, okay, 3 to the first is 3 times a half. That's 3 over 2. That's equal to 1.5. So we've got fairly small values here, so this might be a good time to maybe break your graph up and say, okay, I'm going to go every 2 blocks is going to be 1. Okay, when I go down, every 2 blocks is going to be 1. Okay, so negative 1, positive 1/6. Right there. At 0, I'm at a half. Be right here. And at 1, I'm at 1.5. You're going to see a curve going up like this. Okay, all of these represent growth because as you move to the right on the graph, you're going up. Your y values are increasing. So those are all growth. Okay, an exponential growth model here. C is the initial amount we start with. Okay, T is the period of time. R is the rate of growth. Okay, so we're going to use this formula. Okay, I'm going to, instead of C, a lot of books use the letter A. This is a formula that we're going to use. So what happens, it says the owner of a 1953 Hudson Hornet convertible. That's a car. You watch the movie Cars, the dock in it was the Hudson Hornet. Going to sell it at an auction. The owner bought it in 1984. This was its initial value. So that's the A value. That's going to go in for A. The value of the car increased at a rate of 6.9%. That's my rate. Okay, 6.9%. But I'm going to change that when I plug it into the equation. I have to change that to a decimal. I take it out of the percentage. So it says write a function that models the value of the car over time. So you'd say y equals 11,000. That's my initial value. It's always 1 plus the rate. Now, I can't leave this as a decimal. So to take it out of I can't leave it as a percent. To undo the percent, you divide by 100, which that's going to move your decimal point over 2 places. So I'm going to put the decimal in 0.069. Okay, and I'm going to raise it to the power of t. Okay, that function models it. Now they might add those together instead. You could say y equals 11,000 times 1.069 raised to the power of t. Okay, so you could add those together in your model. Then it says at an auction in 2014, what was the approximate value of the car? Round to the nearest dollar. So you got to go from 1984 to 2014. How many years passed? Okay, well, 2014, if I subtract 1984, okay, 30 years have passed. Okay, so 30 years, that's my t, that's my time. So I'm going to take that equation, I'm going to raise it to the 30th power. Okay, I'm going to grab a calculator real quick. Okay, when you do this on your calculator, and you might be using your phone, that's okay. Okay, but when you use your calculator on this, you have to evaluate your exponent first. So I'm going to plug in that base of 1.069. Okay, I'm plugging that in first, and then I'm going to raise it to the 30th power. Oh, this calculator might not work. Yeah, I got things broken on this calculator. So I'm going to use my phone. So you may have to turn your phone on its side to get your bigger calculator. Okay, the key that is a power key, my key looks like this. It says X with a little Y to it. So I'm going to put the X in, that 1.069. I'm going to hit that key, and I'm going to raise it to the 30th power. And I get a really long decimal. Now don't clear that, don't round it. Just leave the decimal that you got, and then you want to multiply it times 11,000. So you're going to hit times, and then put in 11,000, and then hit equals. And that is your value. Okay, and it says round to the nearest dollar. So look at your cents. Mine says $81,418.64. That's going to round up to $419. So $81,419 is what that value of that car would be after 30 years. That's a pretty good investment when you have an antique like that. So, okay, go ahead, give your worksheet a shot, see what you can do on that. Join the Zoom if you have questions.